Okay. Now let's talk about something very interesting. Okay. So now the interesting part is that merge to sorted arrays is a very interesting algorithm for a reason. First, this is one of those algorithms that gives you a complexity of m plus n. Right? It's not mn, it's m plus n. That makes it interesting. It's a two-pointer algorithm. That makes it interesting. And one more thing makes it interesting, which is it acts as a subroutine, or you can say it's act as an internal function for one very famous sorting algorithm called as merge sort. One very famous sorting algorithm called as merge sort. What is merge sort? Merge sort is one of the most simplest algorithm to solve, I would say. One of the most simple algorithm to solve. What does merge sort say? Merge sort says that if, let's say, you have an array, okay? You have an array. And let's say the array looks, it's a random array, okay? 4, 1, 6, minus 1, 3, 8, 2. Okay, it's a random array, initial array. Okay, what merge sort says that if somehow you divide the array into two equal halves, or approximately two equal halves, for example, here you can see the length of the array is 7. So if you divide the array into two halves, so two halves will be 6 plus 0 by 2, that is 3. So this will be the two halves. Okay, this half is 4, 1, 6 minus 1, and 3, 8, 2. If let's say you divide your array into two equal halves, and somehow you sort the left half, and somehow you sort the right half, what will happen if you sort the left half? It will become minus 1, 1, 4, 6. If you sort the right half, it will become 2, 3, 8. Can I say that? If somehow you sorted it, then what you can do is you can merge these two as two sorted arrays inside your original array, right? So it will be minus 1, 1, 2, 3, 4, 6, 8. Can I say that? Right? That is, if let's say you divide your original array into two equal halves, you sort the left half somehow, you sort the right half somehow, and then you merge the two sorted halves as two sorted arrays in the original array, you will get what? You will get the final array as a sorted array. But you might be thinking, okay, who will sort the left half and the right half? Who will sort the left half and the right half? This is where we will put recursion in place. Remember recursion? In recursion, what do you have? You have a base case, you have a assumption, and you have a self task or a self work. Okay. Now, what can be the base case here? Can I say array of length 1 is already sorted? Can I say that? Array of length 1 is already sorted. That will be the base case. And what will be the assumption? We want to write a function merge sort. We want to write a function f as merge sort. Right? We want to write a function f merge sort. What it will do is it will take an array and it will take a initial part low and an ending part high. Or you can say start and end. You can also say start and end. And what this function is going to do, this function will apply merge sort on array from index start to end in this region. So initially your start is 0, your end is 6, right? And you have to apply merge sort here. So what does the algorithm of merge sort says is that you divide your array into two parts. One half, one more half. You recursively apply merge sort here because merge sort is going to eventually sort the array. So you recursively apply merge sort on the left half, you recursively apply merge sort on the right half, and then that's the assumption that when you recursively apply merge sort on the left half will be sorted. When you recursively apply merge sort on the right half will be sorted, and then you merge the two sorted halves. But you might be thinking, sir, what do you mean when you say recursively apply merge sort on the left half will sort the array? Let me actually show you. So just apply the same algorithm here as well. What was the algorithm? Divide the array into two parts. Let's divide the array into two parts here also. Okay. We'll divide the array into two parts here also. This is index 0, 1, 2, 3. This becomes 4, 1. This becomes 6 minus 1. Divide the array into two parts here as well. 6. So here 6 plus 4 by 2 is 10. So, okay. This is 3, 8, and this is 2. Okay. And then again, now what was merge sort here? If you would have to apply merge sort here, what do? You divide your array into two halves. You recursively apply merge sort on the left half. You recursively apply merge sort on the right half and merge. But who will apply recursively merge sort? Actually, merge sort will be applied, right? So again, you will do the same thing. Same thing here. You cannot divide this 2. So 2 remains as it is because it's a single element. 4, 1, 6 minus 1, 3, 8. Can I say that? And now things will start becoming interesting. Can I say you started from here, you divided your array into two halves. You came here. You divided your array into two halves. You came here. You divided your array into two halves. Now this is what? A base case. 4 and 1 are already two sorted arrays. And you know, single element is a sorted array. If you have two sorted arrays, why not? merge the two sorted arrays to make it 1. So this will become 1 here and this will become 4 here. Can I say that? Right? So what is happening? Now you're going back in the recursion, back to the original part, and you're merging the two sorted arrays. So we got 1, 4 here. Same thing to the right half of this. You divide it into two parts, 6 minus 1. Again, it's a base case. So you try to merge the two sorted arrays, and this will become minus 1, comma 6. Now again, you have two sorted arrays. You merge the two sorted arrays to make it minus 1, 1, 4, 6. Then you go here, 3, 8, 2. You divide it 3, 8 like this. 3, 8 is already sorted because you can see 3 and 8 will become single element. This is already sorted 3, 8. And now this is a sorted array. This is a sorted array. You merge the two sorted arrays to make it 2, 3, 8. And can I say, after all of this internal recursion, you will land up in a situation where this half is sorted, this half is sorted, and you have to apply merge two sorted arrays on this array and this array. Can I say that? Can I say that? So that's the power of recursion. So what this function will do is, this function will calculate the mid, which will be start plus end by 2. And then what it will say is that, it will say, recursively go and sort the left half. This left half is from start to mid. Go and sort the right half. Right half is mid plus 1 to end. And then merge the two sorted arrays. So this will return you a sorted array, let's say left. This will return you a sorted array right. And then you merge the two sorted arrays left, comma right. Are you able to get this point? Are you able to get this point? So merge sort uses the power of merge two sorted arrays to recursively sort the array, right? To recursively sort the array. Let's try to actually code this solution, and then we will be able to get a better perspective, and we'll try to do a small dry run as well to actually see how merge sort is working. And I will do the complexity analysis of merge sort that is going to blow your mind actually. Let's try to code merge sort. Okay. So I'll create a new file, merge sort.java. Okay, cool. First of all, I'll write a function public. I'll write a function public int merge. Okay, what it is going to do, it is going to take a left array, it is going to take a right array, and it is going to merge the two sorted arrays. This left and right is going to be sorted array, and it is going to return an array eventually. Okay, so for this, I'm going to just copy the algorithm from here. I'll just copy the algorithm from here. Copy, paste, and instead of copying here, I will just return result. Okay, instead of copying like LeetCode, I'll just return result here. Make nums2 as right, nums1 as left. Here also nums1 as left, nums2 as right, left, right. And you can see m and n we need. So what is int m is equals to left dot length, int n is equals to right dot length. Can I say that? Okay, so you can see I have modified my merge algorithm such that now it is not modifying the nums1 or the left array, it is actually returning the resultant array. Okay, and everything is same, the same algorithm is there. And now I'll write a function public void merge sort. It will take an array to merge sort, right? And we'll write one more function public void merge sort helper that will take your array. It will take the start, it will take the end. And from merge sort, I'm going to eventually call merge sort helper with start as 0, end as array dot length minus 1. Okay, now let's implement merge sort helper. Let's implement merge sort helper. So what is going to be happening with merge sort helper is, we'll calculate the mid. Int mid is equals to start plus end by 2. Int mid is equals to start plus end by 2. Then what we are going to do is, we are going to get the left half sorted, right? How? We'll call merge sort helper on the left half. What is the left half? From start to mid. Then we'll get the right half sorted recursively. Merge sort helper mid plus 1 to this, and return type should be public static int. Okay, return type will be this. And then what we are going to do is, we are going to merge the two sorted arrays. So we'll call return merge left, comma right. Can I say that? Okay, this should be public static. Okay, return this. Okay, and instead of just directly returning, what you can do is, let's say you can modify array to be like this, and then or let's do one thing. Let's just return merge here, and whatever is the result of merge sort helper, I will make ARR is equal to that result. Okay, so array will become the new sorted array. We need the base case. What will be the base case? If start becomes equals to end, that means it's a one single length array, right? So you will just return the array. If start becomes equals to end, you will just return that array because that's now a single length array. Can I say that? It's a single length array. Okay, cool. Let's try it out. Let's try it out and see what can be done. So let's say we have an array 5, 4, 3, 2, 1, 0. We'll call merge sort on ARR. Let's try to print array and see if it is working or not. If not, then we will try to debug it. Okay, and let's see what's the issue. Okay, this should also be static. Okay, and we'll say ARR type. Okay, let's see if it is working or not. Okay, let's make it merge sort. Okay, cool. Let's try to run the code. Okay, can you see? Doesn't look like working, right? Doesn't look like working. This is actually printing the same to same array again, right? This is actually printing the same to same array again. What's actually happening? Anyone? This is actually printing the same to same array again. Are you missing a step? Missed static. No, I've added static already. No worries. Anyone? See, the merge to sorted algorithm, array algorithm is pretty plain and simple. So I'm just closing that out. This is the actual merge sort that we were doing. See what is not working well. See what is not working well. Not calling recursively. Which part? What's what I was add करना है? Didn't get you. Hi Kalyani. Okay, let's try to see what is actually coming up. Okay, so let's say I'll make a array int result is equals to this. Okay, let's see what is coming out in result here. Okay, let's try to debug. Okay, result at I. If you run the code, can you see this resultant array was also coming like this only? That means merge sort helper has some issue. It is not returning the result properly. Can I say that? Let's come to the merge sort helper. This might be causing issue for us. The issue is in the base case. Okay, the issue is in the base case. Let me actually show you. Let's revert it. Okay. Now the issue with our code is in this base case. In the base case, we have to return a new array, right? If start becomes equals to end, right? We have to return a new array of a single length because every time you can see we are returning a new array. But whereas here, I just returned the array ARR. So what I'm going to do is, I'll say int result is equals to new int of length 1. Result of 0 is equals to ARR of 0. And then I return result. Okay. This, what it is going to do, it is going to return a new array of a single element. Just think about it. If let's say you have a 2-length array, you call merge sort on the left half, you get a new array. You got merge sort on the right half, you got a new array. And then you return the merged sorted array. Let's try it out now and see if we have still any issue or not. If I run the code, you can see still there is an issue. Still there is an issue. Why? Because this should be, first of all, ARR.start, right? This was one mistake. This should be ARR.start. If I run the code again, still we have an issue. Now, what is still left? What is still left? Anyone? See how iteratively we are improving, right? We saw that, okay, there was one issue that was coming up here. We resolved that issue. Any other issue you are able to spot? Let's see what's result here. Let's see what is result here, okay? That is whether our merge to sorted arrays is working fine or not. So I'll say result of merge to sorted arrays, and we'll just put a loop. Result dot length m is equals to 0, m less than result dot length, m plus plus. This is result of, and not only m, let's make it like what, L. Okay, because m is previously being used. Okay, let's see what's coming in the result. If I run the code, okay, can you see it is indeed merging the two sorted arrays 4, 5, 3, 4, 5, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4, 5. Can you see it is indeed merging the two sorted arrays properly? Can I say that? Can you guys see? It is indeed merging the two sorted arrays properly. That means we are getting the result here correctly, but we are somehow not handling it here well. Can I say that? Yes or no? See, our individual pieces of the algorithm is working. The only thing is, this gives you the left half correctly, this gives you the right half correctly, this merges the two halves correctly. How do you allocate it back? Look at this diagram. Look at this diagram. This is giving you the left half sorted correctly. Here, giving you the left half sorted, or here, let's say, this is giving you left half array sorted correctly. This is giving this sorted correctly. You have to merge it back. How do you do it? Anyone? I can show you the result again. Like, you can see individual results of the merge is working fine. And I can also do one thing. So star, so that you can see individual results. Okay, you can see the final result of merge to sorted arrays is working fine. 0, 1, 2, 3, 4, 5. Can I say that? What do you mean by recall? Why do you want to recall? Guys, anyone? We are already doing that in merge to sorted arrays, right? Okay. Now let's do one more thing. Let's make result here, and let's bring this one here. Okay. Result, and you can say result of merge sort. Let's see what's the result of merge sort coming as. If you run it, can you see now result of merge sort is also coming properly? That means here also we are getting things properly, yes or no? Can I say that, guys? See, now here also result we are getting properly, yes or no, guys? Okay. Now what we were doing, we were allocating it back to ARR. We were allocating it back to ARR, this ARR. ARR, ARR. Let's see if it is working for not ARR or not now. Can you see result of merge sort is working fine here as well? Then what is the problem coming up here? Let's see who all have done Java well. Base case issue we already sorted out. Base case was the issue initially, we already sorted it out. You can see here also we are getting the result of merge sort correctly, but when I call merge sort here and I call array here, it is not working. Anybody? Very good, Narottam. Very good. What about rest of the people? I want everybody to think and answer. Okay, let me help you with this. It's a simple Java concept. It's a simple Java concept. Okay. Let me remove all the logs for a moment. It's a simple Java concept. Okay. And ARR doesn't work here in Java. It's not C++. Okay. So now everything is working fine for our algorithm. The only issue is that here, when you create int ARR, right? When you create int ARR and you modify this ARR, it's kind of like the local variable ARR that you are changing the reference to. This original array, for example, let's make it as array so that you get a better naming convention. Okay. So what you're doing is you are bringing the answer of merge sort helper and allocating it to the array. What's happening is this local variable array is now getting the reference to the new sorted array, but this original array in the main function is not going to be changed for the reference. So what you have to do is you have to make the return type like this. Okay. Or in simpler scenario, you can just return this and here you can allocate it back here. You can see that. So whatever is the array that is being returned by merge sort, which will be a new array, is now going to be allocated to this particular ARR variable. If now you run your code, can you see the array is sorted? And now you can try any combination. For example, let's try an already sorted array. You can see it is working. Let's try an array of all same elements. You can see it's working. Let's try some jumbled array. Okay. And -4, -9. Okay, let's try it now. You can see things are working properly, right? So what we did, we used the same merge to sorted arrays. The only difference is we are now returning the resultant array. Then we called our merge sort helper, which is a recursive function. When the length of the array is same, it returns a new array of single length. You get the left half, you get the right half, you merge the two halves, and then you return the new array and allocate it back here, and allocate it back here. As simple as that. Or you can call merge sort helper directly from the main function as well, but generally you will find people calling selection sort directly by passing the single array. You don't want your end user to be aware about the fact that, okay, how you are actually handling 0 array.length -1 here. But again, for a DSA question, you can actually do that. And that's how you can actually implement merge sort. Are you guys able to get this point? How this actual function is working? Let's have a quick dry run. Do you want a quick dry run? Let's have a quick dry run. Okay, cool. So I'll just take this much part. I'm not dry running the merge to sorted arrays because I believe that is more or less understandable, right? And let's cancel this one. Let's take a new screenshot here. Guys, are you able to get a hang of how merge sort is working? Just a second. Just a minute, guys. My application is updating. Okay, cool. So let's bring it here. Okay. Okay, cool. Now let's dry run and always keep the merge to sorted arrays in your mind. Let's do a quick dry run of merge sort. Okay. So let's say the original array that you have, is 3, 2, 1, 0. Okay, let's take a small array so that we can dry run it quickly. Okay. So you will call in the call stack. This is the call stack. You are going to call merge sort on the given array. This is the given array. Okay, original array. What is merge sort going to do? It is going to call merge sort helper. It is going to call the helper with array, which is this array, 0 and array.length -1, that is 3. Okay, array.length -3. Cool. We are now going to call merge sort helper. Okay. Now, is the start equals to end? Is the start value 0 equals to the end value 3? No. That means you will calculate mid. What is mid? 3 plus 0 by 2, which is 1. 3 plus 0 by 2 is 1. Now, what you do is you will say, let's recursively sort the left half. Let's recursively sort the left half. Okay. So what we are going to do, we are going to call a recursion on line number 49. So I'm going to leave it on line number 49 and I will call helper again on the same array, ARR. Start is 0 and in the end, we are going to pass mid. What is mid? 1. Can I say that? Recursively call this. Is start equals to end? Is start equals to end? No. So You calculate mid. 0 plus 1 by 2 is 0. And you again make a recursive call. So you leave this function on line number 49 and you make another helper call with array 0, 0. Can I say that? Now this same original array is being passed. Can you see this same original array is being passed? Okay, cool. Now, is the start equals to end? Yes, it is. And remember, previously I was just returning array. If you return the same array, you can see you have not returned a sorted array, right? When start is equals to end, that means you are referring to a situation where you just have a single element. So that's why I create a new array result. Okay. And I store ARR of start, that is 3, and return it. So you can say, we are going to return inside left a new array 3. Can I say that? Right? We can return a new array 3. Why you cannot do return ARR of start? Because the return type of this function is an array. You cannot return a integer, right? So always you have to create a new single length array, store the element in the array, and return that array. So when you return, right, this function is going to be removed. Where did you left it? You left it on line number 49. On line number 49, whatever is the return value is going to be stored inside left. So can I say left is equals to 3? Yes or no? Right? Left is equals to 3 because it got returned from the base case, right? Make sense, guys? Is this point making sense? Only network side, yes. Cool. Now, after line number 49, what is the next line to be executed? The next line to be executed is line number 50. On line number 50, what do you say? Again a helper call. Again a helper call to the array mid plus 1. What is mid? 0. So 0 plus 1 is 1. And end. What is the value of end? 1 only. Can I say that? And again, you left it on line number 50. Okay. Start is equals to end. So you return a new array of length 1 where you store ARR of start. What is ARR of start? 2. So what is going to happen? You are going to return right is equals to 2. And that's it. Can I say that? So you left it on line number 50. So whatever is the return value of this function will be stored inside right. So can you now see? You have a left, a new array 3. You have right, a new array 2. Both of them are sorted arrays. What do you return from here? You merge the two sorted arrays and return a brand new array. So from here, you return 2, 3. Can I say that? You return 2, 3. And when you return 2, 3, you go back here where you left on line number 49. On line number 49, whatever is the return value is stored inside left. So this function is done. And you store it inside left. You store 2, 3 inside left. Okay. Now, after line number 49, what is next to be executed? Line number 50. On line number 50, what do you say? Again, a helper call to ARR, comma, mid plus 1 and end. What is mid? 1. So 1 plus 1 is 2. And what is end? End is 3. Can I say that? Right? End is 3. Okay. Is start and end equal to each other? Is the value of start and end equal to each other? No. You calculate mid. Mid is 3 plus 2 by 2. 5 by 2 is 2. Okay. So on line number 49, you're going to make a recursive call. So line number 49, you leave it on line number 49 and you make a helper call to ARR, comma, start, comma, mid. What is start? 2. What is mid? 2. So 2, 2. And now here, is the start and end equal to each other? Yes. So what you do, you create a new array, store ARR of start. What is start? 2. So what is ARR of 2? 1. So you store a new array and which has a value 1 and return it. So you return, let's remove this array. So you return a value 1 which gets stored inside left. And why stored inside left? Because whatever you return, you left it on line number 49. So whatever you return is stored inside left. Okay, cool. This is done. After line number 49, what should be executed? Line number 50. Okay. On line number 50, you again have a helper call. ARR, comma, mid plus 1, comma, end. Mid plus 1 is 3, end is 3. 3, 3. Again, the base case will hit. And what you are going to do is you are going to return a new array 0 because ARR of 3 is 0. And that's it. And because you left this function call on line number 50, line number 50 was calling a function and its result is stored inside right. So this becomes right. So now left is 1, right is 0. Can I say these two are two sorted arrays? So after line number 50, what will happen? Line number 51, which merges the two sorted arrays and return. So what are you going to return? You are going to return 0, 1, right? You're going to return 0, 1. This function is done. Right? And you left it on line number 50. So whatever is the result of this function is stored inside right. So I will store inside right. And now again, you have left and right. 2, 3 is a sorted array. 0, 1 is a sorted array. You merge the two sorted arrays and return. So what is the merge value of the two sorted arrays? 0, 1, 2, 3. And you return it. Can I say that? Where do you return? You return in the call of merge sort. So here you got a new array 0, 1, 2, 3. And can you see that's the sorted array? And then you return this 0, 1, 2, 3 in your main function. And inside your main function, you are allocating it back to the original array. That's how actually merge sort works. Is that dry and making sense to everybody?